Today we're going to prepare the generative adversarial network that we discussed in the previous video. And here I have a new code file using Google Colab, but you'll also want to open the lensing CNN code that we had earlier. If you're only here for the GANs and you didn't watch the CNN series, I have the code on the GitHub, so you could just download that. And then if there's some things that you're confused about, feel free to watch the video on preparing that data set. So anyways, all we have to do to start off is copy and paste a couple blocks of code. So we'll copy these two. So import the necessary libraries. We'll unzip the data that we'll load in. Let's see. Just make sure that everything's running correctly. So let's show some image samples. We need to set up our transforms. And what else? We need our image data set to help load in our data. We'll need to create the data loaders. We'll need to test to make sure that our batches are loading correctly. And then now we're going into our neural network. So I'm just going to copy and paste the convolutional neural network. I know I already went over a smarter way to build neural networks, but I'm going to use this version because it's easier to understand the processes that are happening within the neural network. So we'll just stick to this version. And what we'll have to do is, instead of calling it convolutional neural network, we're just going to name it Discriminator. And if you remember from the last video, the Discriminator is essentially just a convolutional neural network. We won't need to change anything here, so this is okay. And what was different though was the generator. Only slightly different though. So we're going to rename this generator. We also need to do it in the super function. And then we're also taking in the size of our latent vector z. So if you remember, we have the z vector that contains a set of random numbers. It's the base encoding that could be transformed into the various feature maps being used by the generator. And what I said earlier was that the generator is essentially the transpose convolution. So all we have to do then is put the word transpose in our convolutional layers. And what happens is, instead of starting from the number of channels, because remember we're creating images, so we want to output the number of channels. So we put that here, and what we start with is the size of the latent vector z. And because we're starting off with smaller feature maps, we're going to want more of them. So we're going to reverse the way that we create the different layers of feature maps. So instead of starting low, we'll start high, and we'll cut in half at every next layer. And then because we're starting off with the small feature maps, we need to reverse this as well. Hey guys, the continuity here might be a little messed up, but I had to butt in here just to remind you guys to change the number of layers that you are normalizing because we reversed the process. So this will be a very important step that I forgot to record earlier. So now that's fixed and we could return to what we were doing earlier. And that's basically it, except now we need to change this to Tange. And the reason we use Tange is, for one, it squashes the values between two boundaries. So the Tange function, if you remember, it goes from -1 to 1, and it's centered around 0. And that could be proven useful for statistical reasons. And then also we can't really use ReLU because it's not really bounded. It could just grow and grow, and if you think of images, they have a bounded set of pixel values. They could be between 256 and 0, depending on the image type that you're working with. So that's why we want to use a bounded activation function, and then it's also helpful to be centered around 0. So that's why we use Tange in the output of the generator. And what we do next is I renamed the generator, so you just need to change the name here, and that's basically it. That's all there is to setting up the GAN. I'm going to change these names to Discriminator just so it doesn't get confused, I guess. I think it's better to have more explicit names for your networks. But yeah, that's it. All we needed is the discriminator and the generator, and now we're ready to work with GANs. In the next video, we'll start to train them. There's a little bit of stuff that I have to review in terms of the loss function, because how do you tell a network to optimize the generator and optimize the discriminator? Because in the previous videos, we only went over how to use like a single loss graph, and that was pretty intuitive. But because of this adversarial approach, there's some more things that we need to go over. So I hope to see you in the next one. Peace.